Our previous example showed us how to find the 6 trig functions if our angle is between 0 and 360. Now, this is a procedure to show us how to find trig function values of any non-quadrant angle, theta, which means on step 1, our angle is greater than 360 or our angle is less than 0. Then our procedure is to find a coterminal angle by adding or subtracting 360 as many times as needed to get an angle greater than 0 but less than 360. Step 2 is to find the reference angle. Step 3 is to find the trig function values for the reference angle. And step 4 is determine the correct signs for the values found in step 3. This gives the values of the trig functions for angle theta. Our first example asks us to find exact values of the 6 trig functions for each angle. Rationalize the denominators when applicable. Our first angle is a negative 1,665 degrees. From the previous slide, we know we have to find the coterminal angle, or an angle that represents this angle that is between 0 and 360 degrees. To do this, I just use a calculator, and I'm going to add 5 revolutions to get my angle to represent 135 degrees. So my coterminal angle being 135 degrees to represent a negative 1,665. Let's continue by representing this angle on a coordinate plane. I drew my initial angle, and then I did a clockwise motion to represent 135 degrees. I then always draw a vertical to my horizontal x-axis, whether I'm on the right side of the y-axis or the left side of the y-axis. Then I find a reference angle to my 135 degrees. In this situation, it is a 45 degree angle. This reference angle allows us to create a right triangle that is going to be one of our special right triangles, in this case, a 45, 45, 90 right triangle. What we want to do is always find the measure of r. In this case, if there is no measure given, I'm going to assume it's 1. We're always going to assume it's 1 because that's the easiest value that we can have a unit represent. Plus, mathematically, that's going to give us the easiest number that we can work with inside of our problem. Recall from the special right triangle video that when I'm given a hypotenuse, I need to find a leg. To do that, I just take the hypotenuse, which is 1, and divide it by the square root of 2. And then what I need to do is to rationalize. 1 over the square root of 2 times the square root of 2 over the square root of 2. And that gives me a value for each leg to be the square root of 2 over 2. And also notice, for the x value, I made it negative because of the left side of my y-axis. My x is negative, and here, for the y value, this will be a positive square root of 2 over 2. Now that we have values for x, y, and r, we can substitute these into our 6 trig functions and evaluate them to answer the questions. So sine of theta, which is a negative 1,665, is going to equal y over r. But since we have r equal to 1, actually sine theta is just going to be our value for y, which is going to be the square root of 2 over 2. Cosine theta is going to be x over r. And again, since we set r equal to 1, our value for cosine theta is just x, which equals the negative square root of 2 over 2. Tangent theta is going to be y over x, which will equal a square root of 2 over 2 over a negative square root of 2 over 2, which will equal the square root of 2 over 2 divided by a negative square root of 2 over 2. This will be the square root of 2 over 2 times a negative 2 over the square root of 2. And then when I simplify, that will equal a negative 1. To complete this problem, all I need to do is find the reciprocal functions of each of my 3 functions and make sure I rationalize. Let's take a look at an example from the previous slide. Finding the trig function values using reference angles. Here we want to find the exact value of the expression. In this situation, it's tan of a negative 240. From our previous slide, step 1 tells us that we need to find a coterminal angle. In other words, we need to get this angle negative 240 between 0 and 360. So I will take a negative 240 plus 360, which gives me 120 degrees. Step 2 from the previous slide tells me that I need to find a reference angle. And in this situation, from my coterminal angle 120, I'm going to take 180 minus 120, and my reference angle will be 60 degrees. A diagram of that looks like this. My initial side of the angle, 120 degrees. We drop a vertical, and that gives me my 60-degree angle for my reference angle. Step 3 tells us to find the trig function values for the reference angle, and step 4 tells us to determine the sine of that reference angle. So in step 3, we want to find the tangent of our reference angle, which is 60 degrees. We know from previous sections that the definition is y over x. From a reference angle being 120 degrees in quadrant 2, then what I need to do is determine the sine values of x and y. In quadrant 2, I have a negative x value, and also in quadrant 2, I have a positive y value. From my section 2 chart, function values of special angles chart, I know that the tangent of 60 degrees is the square root of 3. But with my reference angle being in quadrant 2, I know that this is going to give me a positive over a negative, which is negative square root of 3. Let's look at a couple more examples. Number 2, cosine of 780. First, let's find a coterminal angle. Remember, we need an angle between 0 and 360. In this situation, we're going to take 780 and subtract 2 revolutions. In other words, 2 times 360. The result will be the cosine of 60 degrees. Now remember that 60 degrees is going to be in quadrant 1. And in quadrant 1, cosine will be positive because we need to recall that cosine is actually x over r. And in quadrant 1, x is positive and r is always positive. So our solution to cosine at 60 degrees is going to be positive. Also, from section 2.1, I know that the special function chart value is going to give us 1/2. And in this situation, since in quadrant 1, it will be a positive 1/2. Our next example is the sine of a negative 405. First, let's find a coterminal angle, an angle between 0 and 360. Here, I'm going to add 1 revolution, which will give us a negative 45 degrees. If I draw that angle up, I'll end up in the quadrant 4. And when I drop my vertical, that will give me a negative y value, a positive x value, and a positive r value. And also, a negative 45 degrees, when I take it going back up to my initial angle at 0 degrees, that will give me a reference angle of 45 degrees. So, let's take a look at 2 things. One, I'm going to use a reference angle of 45 degrees. I have a sine value out front because we need to know that the sine is defined as y over r. And here in quadrant 4, my y value is going to be negative and my r is always positive. So my sine function in quadrant 4 will be negative. From section 2.1 special function value chart, I know that the sine of 45 degrees is the square root of 2 over 2, but in quadrant 4, that value will be negative. Our next example wants to evaluate an expression with function values of special angles. Recall, our special angles are 30, 60, and 45. Here, our expression is the cosine of 120 degrees plus 2 times sine squared of 60 degrees minus tan squared of 30 degrees. If we use our special angle function chart from section 2.1, we know that the cosine of 120 has a coterminal angle, which is 180 minus 120, which gives me 60 degrees. So cosine of 60 degrees from that chart is 1/2. But remember, cosine is in quadrant 2, which means x over r is negative over positive, so I get a -1/2. The sine of 60 degrees, that's already a special angle, is the square root of 3 over 2. And the tangent of 30 degrees, again, is a special angle, and that's the square root of 3 over 3. Those are all from the special angle function chart in section 2.1. Now, all I need to do is to take our expression and substitute in those values. When I do that, it'll look something like this. Cosine of 120, -1/2. Sine squared 60 is the square root of 3 over 2 squared with a 2 out front, multiplying it. Tan of 30 degrees is the square root of 3 over 3, and it's squared. Simplifying, I get a -1/2. The square root of 3 times the square root of 3 is the square root of 9, which is 3, all over 2, squared, which is 4, minus the square root of 3 times the square root of 3 is the square root of 9, which is 3. 3 times 3 is 9. Again, when we simplify, that's going to give us a -1/2. 2 times 3 is 6 over 4. But when I simplify that, that's going to be 3/2 minus 3/9. Solve our fractions, and we get 2/3.